Okay.
I'm Anthony Leonelli.
And our project is on regeneration. Regeneration was once thought to be the science fiction, but with now advances in 3D printing, it's becoming more of a reality. So if you get cut or you get a limb cut off, what our software will do is we'll be able to print you out a new limb or organ. That will get rid of like the organ transplant list, or because most Americans like die without receiving organs in time because the list is so far back. And when you can be born without limbs or you can lose them in all the wars we're fighting now. A lot of disabled veterans are without limbs and they have to transition from having limbs to not. Well, with 3D printing and SolidWorks, we could potentially print them out a new limb and attach it, almost like replacing an organ, and it'd be good as new. And you could use it for military use, as I said, with the veterans, civilian, regular hospitals, government could use it, for the president, and you could even use it in space travel. If you're going to a different planet and you get injured, you have a 3D printer right there, you can print what you need.
So here are some examples of what 3D printing has done so far. There's been a 3D printed here. It hasn't been fully functional, but there has been 3D printed here. And then there's it's just a concept right now, but a 3D printer making a heart. So eventually there are going to be like artificial hearts hopefully. So let's say somebody has a heart defect, they'll be able to just make a new heart for them. And then relevance of biology is that biology is pretty much a study of living things and everything around us. So by this, we would pretty much be able to extend lifetimes for people, and they'll be able to interact more with the things around them and study things more, and we'll be able to learn more. So we would be able to pretty much make biology happen in a way. The method, we would have to 3D print said limb or organ, and then make it adjustable to said person. So it wouldn't be the same algorithm for every person, because I'm smaller than him.
Yeah.
So if I had his leg, it would look weird. So it would have to be changed for every person, and then skin color and all that. And then this is just like a side thing we want to try, is making nanotechnology. So let's say I do lose a limb, we were able to inject the nanotechnology into the newly created limb to replace nerve endings and stuff, and try to repair them, so that way they'll be able to actually feel in that leg. So that was just one thing that we were going for. And so
Okay, questions?
Would you be able to create a whole new person out of that?
No, because you cannot create the brain. That is like, you can create everything, but even if you wish to print a brain, you cannot get the personality aspect into the brain.
Would the part still kind of function like the older part? Like if I were to replace one of my fingers with your 3D printed regeneration, would it still function as a finger and still have the feeling as my finger?
Right now it's just a concept, but when it's fully developed and all the kinks are worked out of it, it should be just a normal finger like you're born with. And you should just be able to function and feel and move and everything.
You know, 90% of the science fiction novels that talk about this end up in some sort of catastrophe. Like people living forever and the earth cannot sustain us or something. I'm not going that route. What I wanted to ask you is, suppose that mass produce this thing. What are the benefits, like the immediate benefits of having limbs everywhere?
Am I hard?
Limbs, organs, what is the immediate benefit? Just one thing, if you can think. Well, what would change a lot?
The organ donor list for hospitals.
Right.
So I guess my question on the biology side of that is the functionality, like I think it's been quite asked, and I know that, yeah, the ear and all of that, it's quite easier because there's not much nerve connections, that's why you don't feel much, you know. But other systems, the way you connect it so that it actually functions like the real thing is the connectivity of your nerve endings and all that. And then with the organs, it's the scaffold. How do you actually, printing is the last part. It's the making of the organ is the biggest ordeal. So I think you guys being the computer programmers, right? You're into the algorithm. I think what you can focus on is writing the algorithm of the scaffold of your organ, I guess. And Dr. Stab has something to say.
So before I came to Florida Poly, maybe a little known fact, I did work in a group that was doing xenotransplantation for organs. Our group actually did the 3D printing is a good idea, except for it's very hard to get cells to act like they're supposed to together. And complex organs like a heart, my bet wasn't on 3D printing the organ, my bet was on genetic transformation, where we can actually genetically engineer organs, and there are many groups that are doing this right now. Genetically engineer, like for my case, what our company was working on was lungs for humans, and this was porcine lungs where you genetically change so many genes so that we can match the organ for the person. And if you look at the research and you want to look at donors list, there's a huge market for doing that. The issue with 3D printing, I think if you do the research, you'll see like they'll do tracheas and they do bladders, and they do relatively decent success because there isn't, you can create a scaffolding and then seed the cells and they'll work. And if you look at the research for transplantation, where they'll do a lot of the veterans that have lost limbs, they've done very good at seeding muscles and having muscles take a scaffolding or skin. They can generate skin like the ear very well, but more complex organs like your liver, your heart, or something where you have a lot of different cell types working together, they don't do very well. Although there is a group, and you'll have to look it up because I don't remember off the top of my head, that recently got heart cells to actually beat or like simulate beating together. And that was a big thing because it's very hard to get these different cells may be made for a purpose, but you can't get them to necessarily work together. And if you look up about the heart, it was recent, like, I don't know, a couple months ago that they actually got heart cells, and you may be able to read up a little bit more on complex organs. But for less complex structures like your bladder, which is just a bag, right? Or your skin or muscle, they actually do very well where they can reseed on a scaffolding and have the cells actually work appropriately. But for larger organs, I don't know if it's going to necessarily be quite the case because they've had a lot of struggling to get the different specialized cells to work together in a way that makes sense.
They have printed a kidney, and they started using like sugar as like for scaffolding, because all the where it
Did the
goes
kidney
through.
work?
Well, they started it because the problem was when you would take away the structure, the kidney
Yeah.
would collapse in on itself. But when they use sugar, it let the cells like harden and get used to almost like a shell. And then when you flush water out, sugar dissolves in water. So
Right, but
actually
did the cells work like the issue with this is that the cells, you could get the scaffolding and put the cells in there, but then the cells don't communicate together as part of their function.
it still needs some research.
Yeah, and so the heart was, they got 2 heart cells to actually beat together on the same rhythm, which was a big thing. And they a lot of times do flush the scaffolding where you can dissolve and leave that collagen scaffolding and then just reseed. But the problem is getting them to all work together doesn't necessarily work, as far as I know.
Yeah, that's the algorithm is what you can now start working on what could be possible, because yours here is like predicting what would be a good scaffold, so that when you put it together, hopefully it will. So you will have to do a lot of research in terms of like, sugar materials. What about sugar materials? If we put this together, will it hold? Will it be better? Because you are not the biologist. You are the computer guys. So you work with biologists, or nanotech and all of that, so that when you write your algorithm and your program, it's based on actual, you know, conditions where the cells grow or all of that, put into consideration. So what's your final poster thing here? What do we expect at the end of the semester? Most probably a design, a diagram of the possibility of what we put together.
Yes, and maybe a prototype of an algorithm that we can.
Right. Okay. Good.